I took a moment to just kind of step away from the computer, just give myself a break. So now let's get into a two-sided t-test. So here we have the alternative on the left and on the right. Okay, so once again, we have some population that we're interested in, specifically the population average. And what I want to do, I want to take data and I want to reach a conclusion about the population average. Okay, well, two-sided test, what's going on is I want to know, is the population average equal to a particular value? And here I'm saying the alternative is not equal to that. Okay, so what we're going to do, I'm going to collect my data. I'm going to take my test statistic, and then I'm going to compare it to two rejection regions. Before, we just had one rejection region on one side. Here we have one on each side. This is a two-sided test. If I see something farther out than my cutoffs on the sides, either side, then I reject the null hypothesis in terms of the in favor of the alternative. Reject the null hypothesis in favor of the alternative. So remember, if I have strong evidence for the alternative, I go with the alternative. Otherwise, I'm going with the null. Okay. So here I need to identify the distribution for testing. I'm going to identify that value. Well, here there is only one value in my null hypothesis. Therefore, it is the boundary one. That's the one I'm going with. In the one-sided test, there's infinitely many. Here, I just have one possible value. Now I'm going to draw the distribution, and I'm going to shade the region that goes with the alternative. All right, so what we're going to do is I'm going to establish my type 1 error risk tolerance. I collect my data. I get my mean, my standard deviation, and the length of my sample. Get my test statistic, 0.59. I'm going to find the cutoff of the rejection regions. Now, something that is important here, I have two ways to do a rejection. All right, now I have a total cumulative risk tolerance. So I split my risk tolerance on both sides. So here, I cut it in half. I cut it in half by 2, right? Divide by 2 right there. So there's my risk tolerance divided by 2. You'll notice that this is my cutoff on the left. And I made a mistake and I didn't cut it off on the right. Oh no, but conceptually we'll work through this. I'm going to show something. I'm going to show why we need to do it this way. So here, this is important. Make sure that when I set up my cutoff for a two-sided test, I use half of my type 1 error risk tolerance. All right, so a negative 2.1, and this one is incorrect. I'm going to show you the difference in a moment. This should be divided by 2. Now I'm going to compare the locations. Okay, so this is the part I want you to pay attention to. Notice this is the correct one. The one on the left was correct, the one on the right was not, because I made that mistake. I didn't divide by 2 on my type 1 error risk tolerance. The correct value is negative 2.1. This should be positive 2.1 here. I made, you see how much bigger this shaded region is. All right, so what we need to do, we always need to make sure that both sides add up to the error that we want it to. All right, so if I see an extreme value to far to the left or far to the right, I will reject the null hypothesis in favor of the alternative. Here, it doesn't make a difference for us because, so we're going to go with the null because, our observed test statistic is pretty solid in the middle. Remember, it takes extreme observation to reject the null. So to reject the null, I need something far to the right or far to the left. Now, I state my conclusion in terms of hypothesis testing. We failed to reject the null hypothesis. I state my conclusion in plain English. Statistically, there is no indication that the population average is different than 0. Kind of funny wording, but that's okay. Now, if I want to use R to compute the hypothesis test, what I'm going to do is I give it X, I give it the alternative, and I give it the confidence level, which is 1 minus the type 1 error risk tolerance. And here we're using two-sided, so I just pass that in here. Here is the hypothesized value, and I get my my confidence interval, and I get p-value, and I get my test statistic and degrees of freedom. All right. Okay, so that's all I've got for you. Take care and goodbye.